Hello, it's Mr. Muller for lesson 10-7, independent and dependent events. Alright, so here we're finding probability of independent and dependent events. So remember, an independent event is when the occurrence of one event does not affect the probability of the other. The dependent event is when the occurrence of an event does affect the other one. So an example of an independent, flipping two coins. Okay, the coin doesn't know that you flipped heads the first time or that you flipped tails the first time and you should get the opposite. Coin doesn't know. You flipping a coin 10 times, completely random. Dependent event would be like you selecting a marble out of a bag and you taking it out, because then, you know, if there's 10 marbles in a bag and there's 5 red, 5 green, and you pick a red one and you keep it in your hand and pick another one, well, now it's not a 50-50 chance anymore because now there's more green than red. So that would be a dependent event. Something you did is going to affect the next time you draw a marble. Okay, so something like this. Adam's teacher gives him 2 lists of titles and asks him to choose 2 of them to read. Adam can choose 1 title from each list or 2 titles from the same list. Okay, so if he goes with 1 title from each list, well, here he has 1 out of 5 books to choose from, and here he has 1 out of 5 books to choose from. So really, he could pick 1 out of 5 and 1 out of 5. If he picks 2 titles from the same list, well, here he has a 1 out of 5, and here he already read 1 from that list, so now he has a 1 out of 4. So this would be one that's listed as independent. This would be one as dependent. Since if he's picking from the same list, he's decreasing the chances to pick another book. Alright, so let's say whether these are independent or dependent. You select a card from a standard deck and hold it. Your friend selects another card. And this one is going to be dependent. Now your friend cannot pick that same card that you just picked since it's in your hand. So it's dependent. You changed what was going to happen. You flip a coin, it lands on heads. You flip the same coin, it lands on heads again. Independent. The coin does not know that you flipped heads the first time, so it's not going to know that it should be tails the next time. That's going to be something that's independent. It doesn't matter how often you do it. Okay, so probability of independent and dependent events. An experiment consists of randomly selecting a marble from a bag and replacing it, then selecting another marble. The bag contains 3 red, 12 green marbles. What is the probability of selecting a red marble, then a green marble? Okay, so I have 15 marbles total in the bag, so I should have 15 as my denominator. What is the probability of selecting a red? So 3 over 15. Then you put it back in. So again, my denominator is going to be 15. If I did not put that red marble back in, it would go down to 14. And then selecting a green marble. So to get these, I'm going to multiply. 3 times 12, actually let's simplify here first. So I have 3 over 15 times 12 over 15, so I can simplify 3 15ths as 1 and 5. And I could simplify 12 and 15 by 3. So 3 goes into 12 4 times, 3 goes into 15 5 times. So 1 times 4 is 4, 5 times 5 is 25. So I would have a 4 out of 25 chance of that happening. Okay, so if I did that 25 times, 4 out of the 25, yes, I would select a red first, then a green. And the reason that odds are so low is because there's really only 3 red marbles, so it's not a great chance that I'm going to select a red one first. A coin is flipped 4 times. What is the probability of flipping 4 heads in a row? So my probability of the first time of getting heads is 1/2. Probability the second time of getting heads, still 1/2. Probability of getting heads the third time, hey, guess what? It's still 1/2. And then the last time, nothing's going to change. It's still 1/2. So 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it's going to happen 1 out of 16 times that I would get heads in 4 times in a row. Experiment consists of spinning the spinner twice, what is the probability of getting 2 odd numbers? This looks like a normal spinner where I have 3 odd and 3 even. Doesn't say I have to get 2 different odd numbers. That would change my probability. So I have a 50% chance the first time and a 50% chance the second time. So I should get 2 odd numbers about 1 out of every 4 chances. If it said 2 different odd numbers, that would change it a little bit. And actually, let's figure out what that is. So let's say it's 2 different odd numbers. So that means my first time doing it, it would be 1/2. But that second time, now I'm only really looking at 2 odd numbers out of 5. So my odds are going to get a little worse. So there's going to be 5 numbers on the board. So let's pretend I got 1 the first time. So we're pretty much just eliminating that 1 part. If it gets 1 again, I would have to redo it. So that means this would probably end up being, instead of 1/4, let's simplify this, it would end up being 1/5. So cutting my odds by about 5% just by saying you can't get that same 1 again.